Today we are going to attempt a mainboard repair. Hello everyone, Chris here. 3D printing controller boards or mainboards have come a long way over the years. Nowadays you can get a 32-bit board with all sorts of inputs and outputs for a very low cost, and it will do pretty much anything you'd ever want to do on a 3D printing platform. But you really don't need one of those fancier boards to get the job done in 3D printing. Maybe some of the older school boards aren't as fast, some of them have 8-bit chips, but a lot of them still have quality components that will get the job done just fine if you just like to knock out a few 3D prints. Enter the Ultimachine Mini Rambo board. And here's a look at the Ultimachine Mini Rambo. It's a consolidated version of the original Rambo board that had a lot more features and pins on it than this one does. This one does feature integrated 4982 stepper drivers and a Mega 2560 chip, so the old 8-bit processor. But all the components that were used on these boards are very quality, and they do get the job done no problem at all. And I still have a lot of these mini boards, including INCI boards, around the shop in different 3D printers, all 8-bit controllers. But the Mini Rambo was very popular at one time. Prusa used them, Simi CNC, as well as Lulzbot, and a long list of other 3D printer manufacturers. And there's always been one thing that I've had to repair over and over on the Mini Rambo, and that's how it deals with the power for the heat bed and the input power from your PSU. Those connectors can be problematic, and because of the convenience that they've added, being able to plug and unplug them, can cause issues, especially since we're running at 12 volts on most of these boards, so the current is just a bit higher. And this board right here is a great example. It has suffered from some of those issues. You can see the 15 amp fuse right here. One of the legs has been heated up, so this has been extremely hot and started to melt the case on the fuse, but didn't trip it. And most of those issues are caused by the heated bed. Again, these run at 12 volt, so even at 15 amp, that's getting pretty high for these type of connectors. By all rights, these connectors should be able to hold 15 amps, or at least up to it, around 12 amps. But if they're disturbed at all or not set up correctly, it's going to cause problems. You can see where the heated bed was plugged in right here. They're starting to get just a bit charred. And the input power for the heated bed over here, the plug that goes in this slot has actually melted. It's left some of it in there. And that's not good. That could cause a fire. Hopefully your firmware protects you from that, but it's definitely going to cause your printer to stop working in some fashion. And for people that have never used these boards, here's a look at the connector. You would attach your wires here from your bed or your power input, and it would just slide into the board like this. This is a Molex style connector, and they've used these to give you some sort of convenience so that you can remove the whole plug, work on the printer, do whatever you had to do. But because of this, if the wires or the connector were to move around at all and cause a higher resistance, it could burn up some of these pins. We're just on the verge of what these pins can hold, so that's why you see some of these melt from time to time. It could also be on the device side, like the heated bed. If those connectors weren't solid, again, higher resistance, you might burn something up. And those pins being burnt up like this is something I've had to resolve many times. Either swapping out the pins, trying to get a new connector, or even soldering the wires for certain things on the back of the board. Because a lot of times, by the time you notice that this is happening, you're either getting thermal runaway or your printer doesn't work at all. The pins are way too far gone to even save them. So I've decided to take a run at this to try to solve it once and for all. At least, attempt to. So my plan was to replace the pins that support the heated bed, as well as the hot end, and the PSU inputs altogether. So remove these pins and replace them with something that might be just a little bit more stable. Also swapping out any fuses that might have been burned up on previous runs. The first thing that I looked at was replacing these Molex connectors and what size they might be. If we take a look at the back of the board, you can see that I've had to repair some of these connectors in the past, but these connectors are actually 5.08 millimeters apart. At least that's how they call them out in the catalog when you try to order them. And after looking around a lot, I found these types of terminals. Now, these are something that you would see on Arduino. We've used them a lot on projects previously. You see these on mainboards occasionally. Depending on the specs that you read, Some places say that these will hold up to 16 amps. Now, I don't know if I agree with that or not, but just the fact that these will fit in the existing PCB, they should be around 5mm space, they do fit, and you don't have a modular plug attached to them, should get us a little further down the road at least. So my thinking is to swap these out with this model here, and just the fact that it doesn't have this removable plug should help us at least a little bit. At least we know that this plug isn't dancing around inside this housing after it gets a little bit of heat applied to it. So if you're getting ready to do something like I'm getting ready to do, swap out one of these connectors, make sure you're doing it safely. You always want to have a fuse in place somewhere in your circuit, especially for things that are higher current like these, as well as you never want to leave your printer unattended while it's operating, especially one that you've tinkered around with. You never know what's going to happen. But I also think it's worthwhile to give this a try because I've seen this issue a lot over the years online, as well as I still have printers that are in use that do a lot of the heavy lifting around here that run these boards. So if I have a process that at least gets this fixed for a little longer than the original connector, this would be really handy to have. So let's go ahead and jump into swapping out the connector, and then we'll do the fun stuff by taking a look at before and after, because I do have a couple of machines that run these boards that we can compare to see if we did any good at all. And just to give us some sort of comparison of before and after, we're mainly focused on the heated bed here because that's the one that draws the most juice. This is Octoprint connected to one of my Mark 2.5 Prusa machines that runs a mini Rambo, and it is running at 12 volt with the heated bed, the PCB style. We call it a Mark 52. But let's see before we make this modification just how long it takes the printer to get up to 110. So we'll set the bed to 110C and we'll kick off the timer. So with the stock connectors, an untouched mini Rambo board that's got a few miles on it, it took 12 minutes and 18 seconds to get from room temperature, which is currently 19C here in the basement, with a bed temperature to 110C. So it takes a while. Remember, these do run at 12 volt. So here's what we're going to do. First thing is we're going to have a Martha Stewart moment, because I am repairing several of these boards. This is the one we're going to repair for the video, but we're going to take this and make it look something like this. So I'm just swapping out those connectors, and I went ahead and swapped out the fuses because some of them are burned or melted. We just want a fresh start here. These are just standard automotive fuses, 15 amp and 5 amp. So to start out, I'm just going to pull these fuses, probably just trash those. You can keep them as spares if you want to, but I don't see much point. And then I'm going to take a flat blade screwdriver and just lift the plastic holder here, this shroud, off of both sides. So I'm just going to get under it and pry it up a bit. This one that already has some of the plug melted in it there might be a little challenging. But once you get a little bit of it lifted, be careful not to hurt the PCB underneath. Then I'll just rock it back and forth with a set of pliers to go ahead and finish removing it. Again, if they're melted, it can be somewhat challenging. So there's one side. This side wasn't as melted, so it's a little easier than the other one. Pry it up. And there's the other side. Now we can move to desoldering these pins. So from the back side of the board, I'm just going to heat up that solder point and grab the pin with a pair of pliers. If you get it warm enough, you don't want to get it too hot, you don't want to mess up the board, but you should be able to get that solder to flow with your iron, and that pin will just come right out. It's a whole lot easier to do these one by one like I'm doing here than it is to try to desolder that whole shroud all one piece. There's one pin, and there's all four. Now we can move to the power input pins. They're down here. There's one of those, and we'll do the rest. And there we go. All the pins have been removed. Now we'll clean up the solder joints a bit. And I do like to clean up any solder that's been left over here. I usually just use some solder wick. It's just a piece of copper, braided copper wire. that you can use to lay over this and get it heated up, and then that extra solder will go into the wick. It's going to be much easier to land that new terminal if the solder has been cleaned up and that hole is clear. If you can't clear that hole with the wick, you can use something like a toothpick or some sort of small rod to make sure that it's cleaned up. If you have a metal rod, just be really careful. You can heat that up and actually allow it to clear the hole a bit. But I'll just go around and clean up all these other terminals. Once we've got all of the spots here on the PCB cleaned up, all these solder pads, we can go ahead and install the new terminals. Now, there's a couple of reasons why I picked these terminals. One, they're readily available. They will hold a ferrule, a 1.5 millimeter ferrule, for 16 gauge wire, and that's what we're going to put back on here. You'll see more of that in a moment. It barely fits, it's real tight, but it will go on there. Also, the space that they leave on the PCB. There's not a lot of room in here around these components for a larger terminal, so there's a lot of reasons why I went with this one, but this is the one we've chosen, so these will go back on now. But with everything cleaned up, these will slide right back in the spots where the stock connectors were. One for the heat bed and the hot end, and then one for the PSU input power. Both are on, and now all we have to do is solder those up on the back. I like to just set the board on something. I'm just going to use my pliers here. It doesn't matter what you use, but make sure the terminal is supported so that it's flush down on the top of the PCB before you start to solder. And then heat that pin up, and then use flux core solder so it flows a little easier. Make sure you get enough solder on that there's no cold joint, but not too much. So that one, that's probably a little more than needed, but it'll definitely ensure that it's nice and solid. And we'll move around to all the other pins. Once the input side's complete, make sure the heat bed and the hot end pins over here are nice and cleaned up, but then we can put in that other terminal. Again, make sure that that terminal is fully seated on the PCB before you complete all your joints. And our new terminal is on. So that completes our fix, but a couple of other things to worry about. It depends how this board has been implemented. Again, I'm replacing these currently on a Mark 2.5 printer. These had the quick connects on them, like this one I showed before. So it was easy to install these. You could pull it off, put the board in, put them back in to connect your PSU, and so on. Now you have these that are going to be stationary, so the wire and the ferrule go directly in here. Depending on the board case you have, you might not have clearance for that ferrule. The one on the Mark II is tight, but you can make it work. Same for these down here. These actually hang out the bottom, so no worries there. We will replace the fuses with some newer ones just to make sure we have good connections. Again, 2 5-amp fuses and a 15 down here for the bed. And also, now that these aren't quick connects, you might want to put some sort of quick connector in line for your PSU inputs especially. I wouldn't mess with these down here. These go directly to your heated bed and your hot end heater. But it might be convenient to pull the PSU, especially if you have some sort of enclosure. And if you're going to do that, one of the easiest ways I've found to implement something like that is to separate it with one of these WAGO connectors. So you can have a 4 or a 5, one of these, however you want to do it, but you can have your inputs and outputs, one from the PSU, one from the board. This will tie them together. Again, 16 gauge wire. 14 would be even better if you can manage it, but I think 16 is about as big as these terminals can go. But that way you could disconnect it. You could have these in line if you ever needed to. Just a thought. I'm not going to do it today on this machine, but it is an option if you needed to do that. So the repair is complete, and you might be able to do this depending on the status of your current board. But I do believe this is going to be a lot more sound solution, especially on an aging machine that might have issues. This is going to give you a more direct connection to the power input, as well as that heated bed. But now for the fun stuff. Really, all we have to do to implement this is swap out the current board that's on the machine with the one we've already fixed up. Maybe you have a spare like I do, or you're fixing the one that's in there. But now we have the opportunity to test both. What does it look like right now with the original Molex connector, and then swap in this new board with the new connector and see if it made a difference. So let's get to the fun part, which is the testing. So here's the printer we're focused on today. This is the Prusa Mark 2.5. This is the one that lives in the bottom enclosure. You've probably seen videos on that before. It's the same one that I just showed you how long it took to get up to 110C before we made any changes. So we're going to take a look at what it looks like now, and then we'll move to swapping out the board and just kind of run some stats. So we know it takes a while to get up to temp. I really don't know the condition of this board at the moment, so let's go ahead and open it up and see if we can see anything unusual. Remember, if you're checking out your board, the common things would be checking out this 15 amp fuse, so we'll go ahead and pull that. It still looks to be in good shape, no melted or burn marks. The connector where the heat bed connects to, we also want to check the other side, but we'll do that in a moment. It still looks like it's in pretty good shape. There's no crunchiness to it. The wires are still in good shape, nice and flexible. They'll get crunchy and hard to bend if they've gotten too hot over the years. And then also we want to check the input power. Both of those look like they're in good shape, no issues here. We did just replace a lot of this a little while ago when we did the enclosure build. So I don't expect these to be bad, but I wanted to give us a good idea of what we were dealing with to make sure we didn't have any problems, so we're getting some decent stats. And we touched on this before, but when you're redoing these connectors, if you're doing something like this, always use wire ferrules like these. These are crimp-on. Again, these are 1.5 millimeter ferrules, 16 gauge wire. These will work both with that quick connect, stock connector, and the new one we're going to be using. It's also important to check your strain relief and the wires underneath here to make sure they're getting good connectivity and they're not moving those actual connectors underneath this guard while the printer's going back and forth. This is the angled strain relief so that you can put it in an enclosure. It just shortens it up a bit. But go ahead and pull all this apart and check it to make sure while we're doing all this work. Make sure the screws are nice and tight. You don't have any wear on the wires. Nothing's crunchy in here. It didn't get too hot. And they have good solid connections on both sides for these ring terminals. I actually found a strain relief part that I like a little better than the one I had on. I printed mine out of ASA. You definitely want to consider printing yours ASA or maybe even PC because it can get a bit warm and start to melt. And you definitely want that strain relief in place. It's also very important to check your thermistor wire. If you're getting issues like thermal runaway, it could just be that your thermistor's come unhooked from the bottom of the bed or that there's a problem with the wire. It's under here, underneath this captain and foil tape. Just make sure it's in place, there's no issues, and no kinks or breaks in the thermistor wire. You don't want to have to go through all this and it turns out to be a thermistor issue after all. So all in all, this Mark II looks like it's in pretty good shape. The board looks decent, there's no burn spots, nothing like that. But I do want to go ahead and replace it with the new board to see if it helps out our stats any. Maybe it can get that bed a little bit warmer, a little bit quicker. But I also want to know just how hot are some of those components getting while it's heating up that bed. Can we actually see that fuse heat up? Does the new connector help those issues? So let's investigate just a bit further. So for this, I just set the bed to 110C on the LCD, and we're going to take a look at the FLIR footage just to see what gets warm inside the box. You can see the bed's already heating up as the wires are, but we'll just kind of look around and see what actually gets hot and what temperature it reaches. So we're on our way to 110C. I've got the hot spot turned on, but I wouldn't expect to see that 110 mark there. It's getting close to it there on those lugs where the wires come into the bed. I would expect it to be a little cooler than that. You can also see some of the components behind there. But if you take a look at this input wire, that's a WAGO connector. And that hottest wire there is the one that supplies power to the bed. I wouldn't expect that to be that hot either. So we might have some added resistance somewhere. So now let's put our upgraded board in to see if it makes any difference. I am going to go ahead and put the wires on. I've got the bed wires here and the power inputs. I'm going to put those on beforehand before I put it back in because they are in a different direction. These are now going to be down. These are coming out where they were coming this direction before. They should still fit. You just might have to play with it a bit depending on the board case that you're using. So all the wires are on. You don't want to bend them too much. You know, they are power wires. There's enough room in the case that they should be just fine. But again, note that if you're putting this back together. So I'm just going to set this in the case and I want to put the cover, the new strain relief, back on the bed. So there's our new cover. The bed's been plugged in and the thermistor, but I do want to go ahead and take another look with FLIR just to see what it looks like after the board's been swapped out before we plug in everything else. So I'll go ahead and set it to 110 and we'll take another look. We're on our way again to 110C on the bed. You can see inside the board here the fuses aren't near as warm as they were before, and the lugs where the wires plug in, even though it's got the cover on, they're not as warm either. So that's good to see. Also on the wires that feed the printer from the PSU, you can see the PSU is now the warmest spot where we were seeing the wires around 40C. So hopefully we've got some things fixed here. So I think we're in pretty good shape. We've got wires and our strain relief on. We swapped out the board connectors. Everything's looking okay. A note on these blade fuses, not all of them are treated equal. Some are higher quality than others. I had some around that I plugged in that were getting really hot. Some don't. So try to get a little higher quality fuse. I'm going to test a couple so I can give you recommendations on which ones to pick. But now I'm just going to put all the wires back on and take the printer back to the enclosure so that we can run our tests one more time. So here we go. Our Mark II has been fixed. It's back in the enclosure. Let's go ahead and test and see how long it takes to get to 110. So not too bad. With the repair, we were able to shave about 2 minutes off of our heat up time. That should also make the heating more consistent. And now that you've made the repair, I would go ahead and run a PID tune. You can do that with an M303 on the Prusa firmware, and then save it with an M500. That might be a good idea anytime you change anything like this, but it might make it even more consistent. So there we go. Our Ultimachine Mini Rambo board is now fixed. Hopefully this is the final one that I have to do. Only time will tell, but I will report back if I see any issues. And we did get a bit of a performance bump as far as heat up time goes, so that is a good sign. Now a lot of people are going to say, why don't you just update it to a 32-bit board and be done with it? They're a lot more affordable and they have more features. Well, there's a couple of reasons. One, I really don't want to have to make another config for a printer like this. It's an 8-bit board, it's more than enough for a Prusa 2.5. Also, I do like the Prusa firmware. They're still updating it, and I don't have to reinvent the wheel or add something like a Raspberry Pi to run it if I don't want to. Also, it feels good to finally fix something that's been bothering me for years on different boards here and there. So hopefully this is the final fix, and we can be done with it, and I'll sleep better at night. So hopefully you found this helpful. That will be it for today, and I'll see you really soon on the next one.